Welcome to the lecture number 17. In previous lectures, we have started the Laplace transform of special function. In that, we have covered the Laplace transform of periodic function. Now, in this lecture, we are going to study the next special function, that is Heaviside unit step function. Heaviside, or it is also known as unit step function. Heaviside or unit step function. Okay. So now what is this Heaviside unit step function? Let us see first definition. Okay. Now there are basically, this particular name indicates that there is unit step. Means what? Let us try to understand this definition. Unit step or Heaviside function is denoted by u of t or h of t, and it is given by u of t is equal to 0 for t is less than 0, and that is equal to 1 for t is greater than 0, greater than or equal to 0. Okay, now how you can draw this in the graph? So look at this. If suppose this is value of t and this is u of t function axis, then for t is less than 0, there is no function. But for t is greater than or equal to 0, the function starts from the value 1 and it remains constant throughout the infinity. Okay, so this is the u of t, that is equal to 1. Okay, so this is called as unit step function. Okay, now what is Laplace transform of this function? So the Laplace transform of unit step function is equal to Laplace transform of, what is the value of unit step function? That is 1. So therefore Laplace transform of unit step function is always 1 by s. Remember this formula. Okay, so this is the first point that we have got here. Okay, now next point, what is meant by displaced unit step function? Displaced unit step function. Displaced unit step function. So what is this? Look at this. Definition. It is denoted by u of t minus a. Okay, now and it is given by u of t minus a is equal to 0 for t is less than a and is equal to 1 for t is greater than or equal to a. Okay, that means in the unit step function and displaced unit step function, the difference is unit step function starts from 0, okay, and it goes up to infinity. The value of that function will remain constant. But in displaced unit step function, what happens? Look at this in the graph. In the graph you will understand clearly. Okay, this is the t and this is u of t here. So here this is 0, but this function starts from this a and it goes up to the infinity. Its value remain unity. Okay, but here there is no any function. So this is the displaced unit step function. So what is the Laplace transform of this function? What is the Laplace transform of displaced unit step function then? So look at this. So Laplace transform of u of t minus a is equal to Laplace transform of u of t minus a is equal to, that is nothing but e raised to minus as into if this minus a, okay, this minus a is go, we can written in the form of e raised to minus s, and what we get inside? Laplace transform of u of t. But e raised to minus s into, we know that Laplace transform of u of t is 1 by s. Okay, so that's why this will be e raised to minus s upon s. So Laplace transform of displaced unit step function is e raised to minus as upon s. Now, third concept here, multiplication by f of t. Multiplication by f of t. That means if you multiply the unit step function by f of t, then what will happen? Okay, so in this case, Laplace transform of f of t into u of t is equal to, remember, just we have to take here Laplace transform of f of t. What we have to do? Just we have to take the Laplace transform of f of t here. Okay. Fourth and important formula, which is also known as second shifting theorem, which is also known as